All right, makes sense. Can you confirm if you can see the screen which shows introduction to elastic load balancing?
Yes.
That's nice. Okay, so welcome everyone. Thanks for joining the session. My name is Ashish and I would be helping you today to understand concepts related to the elastic load balancers. I'm a technical trainer working in London office. It's a little late for me now, but yeah, I am still excited to talk to you all about how load balancing works and what are the options associated with it. I would be using some slide deck which are from some reInvent presentation. I'll be providing link to uh, Raghu so that you can get that link later. And if you want to watch these videos online on YouTube, that shouldn't be a problem. So let's get started. Please ask questions. I'm monitoring chat on a different screen, so I would be able to pick up the question you are asking and probably would be able to respond all the questions, right? So let's get started. Just to keep things little much easier, I would stop video so that you can focus on screen and then I can also focus on delivering this content, right? So I'm stopping video and we will get started now. What is load balancing? A very basic question which most of us has, that why we need load balancer, what is the use case? So I'll show you demos, but let me get started with very basic concepts so that we understand why we need a service like load balancer and what we are trying to achieve from this particular service. If I put a formal definition, this is the best definition I could come up with. Elastic load balancing automatically distribute incoming traffic across multiple target. That is the main idea, that if I have multiple targets available, I don't want them to directly talk to my end users. Maybe what I'm looking for, let's say this is my target number one, this is my target number two, this is my target number three. Now, instead of every user trying to talk to individual targets, let me put something in front. Let's call it Elastic Load Balancer. Let my request come here and be forwarded to the backend. What can be backend, how it work, how we configure load balancer. So we'll answer those questions. But this is a very high level diagram of what a load balancer is doing. It is balancing automatically all the requests across multiple target, and these are the targets at the backend. We will discuss in more detail how and what type of targets are there and how we go about configuring a load balancer, right? So hopefully everyone has some idea on this concept, and we will expand on this particular knowledge now. Now, let's consider that you started building your application. So this is your next big app, your next generation app you created, and now you want to open it for customers so that customers can come and start accessing this application. If I have only one EC2 instance, probably everyone knows about EC2 instances, but if I use a technical word which you are not sure, let me know in the chat and I would be happy to explain it. So this EC2 instance is where, let's say I'm running my PHP application or Java application and I open it for world and users are able to access my application. These users would be coming over internet most probably, but it is also possible that maybe some of users may be internal to my network, so those requests can come internally also. Challenge with here this is that this is a single application or a single instance. So single instance would have some limitation of how much CPU and RAM it can be given. It would have problem if this instance fails, then all my users would be failed. If I have 100 user, maybe my machine can handle the load. But what if I have 10,000 users? 10,000 users accessing, maybe my user performance would be bad. My users would suffer from performance. So that can challenging. That can be a challenging stuff. How we can solve this problem? Why not use load balancer? Let's use the approach like this. Let's have my application deployed across multiple EC2 instances and have a front end. That front end would be then distributing my request to the backend services. I would have the same application deployed multiple times. So this is coming from same image and same application is deployed here, and my request would be sent to different backend services by this load balancer service. So load balancer is used to route incoming requests to multiple EC2 instances, container, or IP addresses in your VPC. That is the main idea of load balancer. Hopefully everyone understand what load balancer is and how it works. Other technical aspect, I would talk about them in a minute. Why we need a load balancer? Anyone, apart from request distribution, anyone sees any benefit of using load balancer? Let me know in chat if you feel there is some benefit of using a load balancer apart from traffic distribution. What are other benefits you can think of a load balancer? Anyone, any thoughts? And questions are only here to make sure that you are understanding fault tolerance. Asim, could be that is little bigger word to say, but yes, I'll discuss that fault tolerance and how it could work. SSL offloading, security, yes, these are something I was looking for. Health check, exactly. So we would be able to perform all these things using our load balancer. Let's try to understand them into a different weather, right? Hopefully everyone knows about basics. So benefit I would get, I would be able to ensure high availability. What I mean by that, if you look at this picture, what I have done, I have kept my AZA. There is one application server running, and in AZB, I have another application server running. Advantage is, even if my availability zone is completely down, there is a outage network connectivity issue, my request will be still forwarded by my load balancer to the healthy instances. So even across availability zone, I can work. So it would create my application in a highly available architecture. Clear? Health check. What if there is a problem with one of my backend services and it is not working as expected? So we may want to perform health check first and only then send traffic to the backend so that we don't send request to a service which is not working. So health check can be also part of load balancer and we'll discuss them. Plus security feature. If you see this picture, what I have done here, I have kept my load balancer into a public subnet, but I have kept my private subnet for my EC2 machine. So all of my machines are in private subnet, and this is ensuring that I don't have to expose my machine at all to internet. Only exposure is at one entrance, and only protection I have to provide at a public subnet, and no need to provide that level of protection on private subnet. But still, we can enforce some security on this if required. So this is how my security feature would be working. Another thing, as somebody has mentioned, TLS termination. So you can say when we are processing HTTPS request, SSL request, HTTPS require lot of processing power in terms of CPU and memory because it is performing encryption and decryption, which means if I have used machines at the backend, maybe 5 to 10% of their capacity would go only for encryption and decryption. What if we could offload that encryption decryption to load balancer and then later I just process normal HTTP request without any issues? So that would be a better way of deploying my service also. So that TLS termination can also happen. And as somebody mentioned, decoupling, now we are able to decouple our architecture and we'll discuss more on that, why we need a load balancer. So hopefully everyone is clear why we need a load balancer. Now, what is today's discussion topic? Load balancing in AWS is a family of services. There are multiple services available for load balancing and they serve different purposes. They have a specific use cases. There are four. I have mentioned three here. I will talk about last one also, but we will talk mostly on ALB today. What is the application load balancer? Sometimes people call it layer 7 load balancer. We will talk about NLB, that is called network load balancer, or sometimes we just call it L4 load balancer, and a very new type of load balancer, that one is called a gateway load balancer. So if I rank them, old, new, and this one is the newest type of load balancer. Newest doesn't mean that this will serve all of the purpose, and oldest doesn't mean that it will not serve any purpose. So it is available. They are, I have listed old, new, and newest based on the release when they were made available to customer, but they have lots of use cases, and you will find lots of customer just use ALB. Gateway may be still making some way to the customer. They are still trying to explore what are the values option. Classic load balancer, Ozgi, I'll talk about that. I have intentionally not mentioned it because it exists, but in a way we are trying to stay away from it. Even when I will take you to the console, you will find that it is not something which we recommend for most use cases. We still maintain backward compatibility because there may be some customer who are still leveraging those classic load balancer, but you will see in screen in a minute that we encourage people to go from any of them. Classic is still there, but not something what we recommend for our application. So let's start focusing on application load balancer first, and then we'll dig deep into how application load balancer actually work. Application Load Balancer is considered to be a feature-rich Layer 7 load balancing application. Now, probably everyone knows about what is load balancing on Layer 7 and load balancing on Layer 4, but I'll explain more on that, how these load balancer actually work and what their decision point they have to decide on how your application would be forwarding traffic or how a response will be given back to you. So let me first try to clarify this setting of what is layer 7 and what is layer 4. Like we discussed, this is a layer 4 and this is layer 3. So let's talk about all these layer concept first. So layers, these are coming from OSI model. Probably everyone knows about it. It is a theoretical model by which all communication happen. All this is not implemented, but this is theoretically considered that communication would be happening in this model, that my application would generate request that will go through my layer that will be called encryption, that will be my encapsulation process, and when it is received at the receiving end, it will go through a decapsulation process, and every layer in between it will add its own information, and that information added by, let's say, network layer will be used by receiving computers network layer. Information on session layer here will be used by receiving computers session layer there. So that's how all my communication happen. Let's try to understand what is difference between our application layer load balancer, what we call layer 7, and what is the difference between a layer 4 load balancer, which we call a transport layer load balancer. Let me try to explain it by an example. Let's take example of a very important person, a very busy person. Let's say Queen of England. Queen of England obviously would be very busy. She may not have time to check everything on her own. And let's say she receives lots of mails every day. When I'm talking mail, I'm talking about traditional postal mails. So people send them postal mails. Somebody's inviting them to marriage, somebody's asking for a financial help, somebody just sending some details to them, whatever. So they would keep on receiving lots and lots of postal mails every day. Obviously, they don't have time, or she doesn't have time to go and check everything. So what she might have done, she might have appointed an assistant. So there is a assistant she appointed, and now she has authorized this assistant that anytime a letter comes, please you check that letter and forward to me only if it is of importance to me, otherwise don't forward those letters to me. So this letter is, you can think, like a request coming to it. Now this letter, when has to be forwarded, the assistant can make two type of decisions. So this, she is my assistant, and she is then trying to read these letter and forward this information. These letters, when received, these letters would have information like to whom it is addressed and from where it is coming. So from, let's say, Ash, and I am based in Harrow in London. So from there I have sent letter. So that is one way of deciding what is this person and who is this person. So this assistant, she can take a decision based on the letter header. Let me just call it header. Header means information like to and from kind of information. That's all we will decide. And this is one way of deciding to send this letter to Queen or not. This is a header level information. Second type of information she may look into. If she thinks that Queen may authorize that you are allowed to open the letter addressed to me, and this time you open the letter and read what is contained, and based on the content only forward me the letter. Don't just forward the letter based on the header information. So what would happen now, that she would open the letter and she would read the content, and based on that the decision for forwarding would be done, right? What we are doing here in content reading, that is basically a way of reading layer 7 information. So this content information is a layer 7 information, or sometimes people just call that this is a application layer information. So if a decision to forward the letter is based on layer 7 or content of the request, we would call that load balancer as a layer 7 load balancer or application load balancer. If content was not checked, only the header information was checked and decision was taken, that we will be calling a layer 4 load balancer, or this is what we call a network load balancer. Right. Now, whether layer 4 and layer 3, this is little debatable. I would say let's call both layer 3 and layer 4, both type of information we can check. Can anyone tell me what are the examples of protocols who run on layer 7? Any protocol who are running on layer 7? In OSI model, if you know which protocols run on layer 7. Anyone? HTTP? Yes, HTTP. These are all layer 7 protocol, HTTP, HTTPS. These are running on layer 7. FTP, yes, we can, but here we can, let's say FTP also. So these are all the requests which are coming here on layer 7. Then any examples of layer 3 and layer 4 protocols? What we run here? Layer 4 protocols. Anyone? TCP, yes. UDP, yes. These are the protocols which we mostly run on layer 4. So if my load balancer is forwarding data based on TCP, UDP, or we can go little further, port number, protocol number, then we would be calling it that this is a layer 3, layer 4 network load balancer. And if my load balancer is forwarding the information backward based on the content of it, we would be calling it is a layer 7 load balancer. So hopefully everyone is now clear that what is layer 7 and what is layer 4 load balancer. What if I ask you a question that who would have better performance? Anyone? Who would have better performance? Layer 7 load balancer, or will it be layer 4 load balancer? Who would have better performance in terms of packet forwarding, in terms of packet receiving? What do you think? Any thoughts here based on what they are doing? Yes, layer 4. See, layer 4. What is happening, Asim, in layer 7? Think of this assistant. She has to open the letter, read the content, and then make a decision. So that would take time, right? This time, what she is doing, she's just saying no need to open the letter. Let me just check what is the header, what is the IP address of source, what is the destination IP address protocol, and let me just forward the information from that. So layer 4 would always perform faster because it doesn't have to process all the information up to layer 7. She doesn't have to open the content of the package. So that is what both type of load balancers are available, and you may decide what would be the best way of for you to implement the solution. So you decide. It is not a either or choice. We will talk about some architecture where you can even implement both into one single location or one single application. Both can be implemented, should not be a problem. So that's how my application layer would work and my layer 7 would be working. So layer 7 is a content based routing. Content based means whatever is there into the HTTP header, what you are requesting. Are you looking for our marketing page? Are you going for a sales server? Are you looking for an admin page? Based on that, your request will be forwarded. So it is route based on path or host field in the HTTP header. And we support multiple domain using a single load balancer in that case. Route each path or host name to a different target group. Now we are using here a word called target group. I had explained what a target group is and how different target groups can be utilized. But this is what is currently happening. Like we are deciding based on what type of data we have, and then we will forward our request to those particular servers. So this is what my load balancer is actually doing right now. Now, when I decide how to forward my data, my decision can be based on what we sometimes call is a host-based routing. Let's see this. Somebody sends a request for orders.example.com, right? Then a request can come for image.example.com. If I want, I could implement that one load balancer only would respond to order.example.com, another one would only respond to images.example.com. This is one architecture. Or I could say These all the services are for my order service. These all services at the backend are for my images service. Let me just have one load balancer, and then it will know when a request comes. It will check, are you looking for orders? Yes, I will forward you here. Are you looking for images? I will forward you here. So that is called host based routing. Means based on the host name you are trying to talk to, we will forward your request. So that is called my host based routing. This is called host based routing. Another option for us could be a path based routing. I'm still trying to talk to example.com, but now I am saying example.com/orders/images, and then we are forwarding requests. So this is called my path-based routing. My data is forwarded based on the path of the request. So it would open the header, read what is being requested, and based on that, forward the information to my backend. So this is called path-based routing, right? So hopefully everyone is clear. Now let's go ahead and see this thing into action, that how I can implement this load balancer and what are the options available for me when I go to AWS console, and I will answer your question about a classic load balancer also there. Another question to you: is load balancer a regional construct, or is it a global construct, or is it an AZ? What is the scope of deployment for load balancer? Is it a global service? Is it a regional service? Or is it a AZ specific service? All right, some answers I'm getting regional and global. Let me explain what it is, how it actually works. So best way to check whether a service is global or regional or AZ based is to go to that service and see how it is deployed. So another question, if I look here, there is no service here in list which says load balancer. Load balancer UI is part of EC2 service, so I have to go to EC2, and in EC2 I would get an option which says that it is a load balancer available inside it. So I would go ahead here and I would be able to see my load balancing option here. So there is a load balancer target groups available. Let me just clean it up so that we don't get confused when we create our own target groups. I am deleting it. Oh, my bad. Listener on a rule. Good, I haven't deleted because this is Oregon. No, I don't want to show it there. Let me go to Ireland. I will create something there. Right. So load balancer is a regional service. Currently, I have selected Ireland as a region, and I will be then creating my load balancer there. Now, two options only if you see this UI. One is to create a load balancer, and second is to create a target group. I'll talk about what a target group in a minute. Let me first talk about load balancer here. Blank, nothing. Let me start creating load balancer. Now, three option. Are you trying to create a application load balancer, ALB? Are you trying to create a network load balancer, or are you trying to create a gateway load balancer? So you have to make a choice here. There is one more option where somebody was talking about classic. Classic exists, but this one is a little old school approach. AWS will be retiring the EC2 Classic network on August 15, 2022. So this existed when we had EC2 machine which could be provisioned without a VPC. If you look at the history of the services, EC2 service was made available before the VPC service was made available. VPC service was created later. So when we had a classic EC2 machine and we needed a load balancer for that classic EC2 machine, that is time where we provided classic load balancer. As you can see, it would be retired. It would not be available anymore. So that's why we just put it like here. In rare case, somebody would use it, but probably we will focus on these three. Let me start by creating a application load balancer here. And I say, let me create a load balancer. A wizard driven process. UI is very intuitive. We can see here more detail that how request will work. Your client will make a request to your application. Listener in your load balancer receive request matching the protocol and port that you configure. So there is a component we will configure in load balancer called listener. Listener will listen to what request is coming in, and then Based on it, it would then forward request to my backend, and here it will forward my request to something called a target group. This photo is really intuitive. It is telling you that what can be a target group. This example, this symbol is for EC2 machine, right? This symbol is for my Lambda function. Does anyone recognizes this symbol? What this icon is representing here? This is EC2 on the very right. Very left is Lambda function. What is this another symbol which is available here? Anyone? Anyone has thought about what this symbol is representing here? They are there for a reason. What it is? So this is a symbol for container service, ECS and EKS. Yes, exactly. This is for container services. So when you deploy a load balancer, you would be creating, this is my ELB, and then ELB will be sending data request to a target group. What is a target group? These are the instances or services who would be responding to us. So what can be a target group? My target group can be made up of EC2 machines. It could be made up of containers, that is also possible, and I can also have a target group which could be made up of Lambda as a function. Lambda function can be used. One thing which is missing here, I would just put it, that is called IP address. So I may have even on-prem environment which have a IP address. I may have created VPN or my direct connect connection, and load balancer of AWS even can forward request to IP address. So a target group can be having these types of targeted if required. So maybe we can create a VPC peering, maybe we can create a VPN connection, direct connect, and even on-prem resources can also receive requests from here. Another example for this IP address mechanism is, if you have ever heard about another new service we offer, is called VMware on AWS. So those VMware machines can also be behind a load balancer provided by AWS. So that is what is called a target group. So these are all the possible targets which I can add, right? So I'm going with the name of a load balancer. Let's call it demo ELB01. I can decide, is it going to be an internet facing load balancer or is it going to be an internal load balancer? What we mean by this, sometime customer may want to create an architecture which is little different than a traditional application. Let me open another paint and try to draw that architecture for you, where we may use a sandwich type of approach with multiple load balancer in there. Give me a minute. Let me open paint again. What I can say, let me have an internet facing load balancer. So this is my internet ELB. I would be then putting my machines at the back end of it, and that may be talking to another services. Maybe let's say this is my web tier, and that web tier may be talking to a app tier at the backend, and in between this web and app also I want to deploy a load balancer, and probably the load balancer which will be here, it would be only talking from private subnet to a private subnet. It won't require any external connectivity. So that type of load balancer we will call a internal load balancer. So you decide how you want to use it. Can I request everyone to mute yourself if you are not asking a question? If there is a question, feel free to unmute. But if you are not asking a question, please mute yourself so that there is no disturbance for others who are joining the call. Thank you. All right. So I will mute it. Yep, I have done that. So this is what my internal load balancer is. Let me quickly go and try to create a load balancer here. I am making it internet facing. I would receive traffic on IPv4 dual stack if I am having requirement to have IPv4 and IPv6 both. And here I would say which VPC I would be forwarding traffic into. So this is a construct which exists within a VPC. You can't say I won't be requiring a VPC. VPC is a mandatory thing. Now, a VPC may have multiple subnets inside, right? And now I can select that I want my target who would receive traffic, maybe they exist into first availability zone. So if I select it, I have to select which subnet in that availability zone where my target would be belonging. So I can say only on this availability zone, and then second availability zone, and these are the only subnet present within my default VPC. It's not mandatory to have all the availability zone added. You may decide that my application would only work from 1A and 1B, never from 1C. So that decision is possible. You can add that, no problem at all on that, right? Then you will add a security group. Default is being added. If I want to add my own security group, I can add. Let me add here maybe like allowing web and SSH. So that will allow web and SSH traffic to my application. Here I am defining a listener. So when I receive a request, that receive request will be on port number 80, where I would forward it to. That forwarding backend is called my target group. And if I had a target group, it would be displayed here. Currently, I do not have a target group. So best would be that I go ahead and create a target group, and I will decide what I want to keep inside that target group. Now, to take a little tangent, what I'm doing, I'm going to deploy a small EC2 machine on which I would host a small Node.js application, a API, which I would access using a load balancer. So I'll quickly go ahead and deploy a small EC2 machine and get started from there. So let's go ahead to EC2 dashboard and create a EC2 machine. And this EC2 machine, I will make part of my load balancer's target group. So I'm launching an instance. I have just created a machine before as a my AMI section, so I have a template available, so I don't waste time in installing something. So I'm going to monolith node.js. This application is very simple application, and I intentionally configured it to run on port number 3000. So my front end request would still come on port number 80, but my backend may be running on a different port number. So that is also possible. So let's go ahead and start this particular EC2 machine. It is okay to have a small instance. T2 micro is fine. Let me move forward with that. And I would say one instance. I would select which VPC it would go into. I would select which subnet it will be part of. And then what would be my other information I want to add with it. So I'm happy to just keep on adding it, and now I am giving it a tag. Let's call it my Node.js application. So this is my Node.js application. That's what I have added here. Instance, volume, and network interfaces all would be tagged with the same thing. This application would be receiving traffic on port number 3000. I already configured in the application. So I have to associate a security group with it, which is able to access things on port number 3000. So I have this Node.js application security group. Intentionally, I have made it very public. All the ports allowed, but I could restrict it if required and only allow those ports once I'm happy. I would say, let me launch my instance. And now this instance is getting ready, right? So that's what a backend instance I am creating for my load balancer. Let it get created. Till that time, we will again try to focus on something called a target group. Now, for you, if you want, you can create a target group while you are creating a load balancer, or you can create target groups separately and then just refer them when we are creating the load balancer. Right, so that is both options available, and later also can be changed, should not be a problem. So I'll go to my target groups and will say I want to create a target group here. Pretty intuitive. Whatever I'm doing from UI can be done from command line. ELB have its own command line mechanism, and through that I can deploy it. See this. What can be in my target group? Am I creating a target group of instance? Am I creating a target group of IP addresses or a Lambda function or even application load balancer? This is where we have discussed that I may have a approach like this. So this is also possible, maybe not this, but even I want to have multiple load balancer behind a load balancer. So that is also possible, or a network load balancer in front and an application load balancer at the back. So those are all valid options. To keep things simple, I am just adding a instance here. Let's call it my node web application. That is my target group name, or let's call this best would be to give it a very easy name, so that let me call it TG. So this is my target group, and my application on this target group is running on port number 3000. I would host it into default VPC. I could select different protocol version, and here are my health check options too. Health check will ensure whether my application is healthy or not. Idea is we are trying to access either a page, you may say index.html, or just the root page, and that would respond back with 200 code. That would be considered a success. If it is responding with other code, I would call it is not successful. 404, 503, those will be all considered as unsuccessful request. And if you want, you can adjust your healthy unhealthy count. So your decision of calling that instance healthy or unhealthy will be made much faster, as we see here. Default is good, but just for demo purposes I am changing. In your production environment, it will depend on how you want to respond to unhealthy instances. And now I am saying fine, done. Till this time my instance is ready, and I can say let me add instance also here, and this is my port group which I will connect to, and I am including this instance into a target group. And now I say create a target group. So my target group is ready. Now, one thing you have to remember, when I told you that target group can have this, that doesn't mean that it can be heterogeneous. Target group is always homogeneous. What I mean by that? When I'm creating a target group of EC2 instances, only EC2 instances can be there. You can't say 4 EC2, 2 container, 1 Lambda, and 5 IP addresses. That won't work. The target group has to be homogeneous, as we see here. So target group has been added. This is ready. And if I go further, I should be able to see whether my instance is there or not. Currently, its health status is unused. We don't know healthy or unhealthy kind of stuff because this is unused right now. Let me now associate this target group with the load balancer we were planning to create. So this time I would say this is my target group, and let's get started. This is one listener. What if I had another request and that would come on different port and will go to different target group? That's not a problem. The same target group can also be part of multiple listener. That is also possible. So maybe this target group can respond on 80 and can respond on 81 also. So same target group can be part of multiple listener, should not be a problem. Right now I am keeping it simple, one-to-one mapping. If I see here, I am deploying an internet-facing IPv4 load balancer security group. This is spanning across multiple VPC, listening on port number 80, and then it would respond back to my request which is coming up. Right. So that is how my application is getting started. And let's start creating a load balancer for it. Right. So this is how my load balancer is getting ready. And what would happen now that my AWS service will assign it a unique DNS name, and this is now into state of provisioning. It may take few minutes to get ready, and once this gets ready, I would be able to access my application by calling this name. This may not be best friendly name for your application. What you would do, you will take this name to Route 53, register a domain, let's say myapplication.com, and create an alias record who would point to this DNS service here, and that would ensure that I am able to deliver my traffic from example.com or mydomain.com to this particular DNS server here. Right. So this is where I would be creating an alias record for communication with this. Okay. Now, let it be ready. This time I have just deployed on a very basic sense that how my standard deployment is happening. One EC2 machine, one load balancer in front, nothing else. Let's see some more options available, like how I can expand it to become a better designed approach for my security. So to explain that, let me go to a different region where I have deployed a load balancer already. I'm going to Oregon, and in Oregon, I have already deployed a load balancer, and I'll show you what is the architecture of that load balancer is. This case, the load balancer which I have, it is talking to this target group, and this target groups are having two instances inside it if you see. And these instances are across multiple availability zone, plus these instances are not in public subnet, but they are into private subnet. So request will come to load balancer, which is in public. It will forward request to the backend, which are in private, and I would have no problem in keeping these instances completely hidden from my external world. So this is my target group, and I would have my load balancer also, which is going to give me a URL from which I would be able to access this application. This is my application URL DNS name, and let me open this application here in a browser. This a sample web page on that application. This one is getting some images from that host. It is getting some DynamoDB information that is coming up, and here we also have display that from which instance is currently responding. So currently this is instance 2b which is responding to this request which has come. Is it load balancing? Let's do one thing. Let's refresh. Remember, my request was forwarded from this instance, which was 2b, and that was part of which availability zone. Sorry, this is my instance ID, and 2b responded to my request. Let me do a refresh and see what happens. See this. Again 2b. Let me refresh it again. See, this time there is a different instance who has responded to my request now. So what is happening at the backend in round robin fashion, my request is being responded by different instances at the same time. So one user will go to A, another to B, same way it would keep on doing round robin, and that's how my request will be routed to multiple applications at the backend. Any questions so far, anyone? Any doubts, any confusions, anything which is not clear, any confusion which is coming to your mind? Okay, so that is my load balancer which we have just created. If I check my application which was getting ready before, this 3000 Node.js application, which is this one, and this should also might have created the load balancer readily now. Let's check that application too. My request will still be on port 80, but the backend on 3000 would respond back to my application, and this is my machine now. State is active. Let's try to access this load balancer also, and let's see what happens. Right, so see this is just not displaying a fancy page. This is just saying ready to receive request, and this is one machine who is responding to all my requests. Similar configuration for creation of load balancer is for network. Nothing changes. So network load balancer, when I say want to create, it would be the same internet facing internal IPv4, what network it would connect to, what would be my listener, where it would be forwarding my request. Then I would then provide that and create a load balancer. So this is also the similar type of mechanism for my load balancer, which is my network load balancer. Advantage of network load balancer is it is faster, one thing. Second, it would always give you a static IP address. In my ELB, I got a DNS name, not a IP address. This may be okay, but some customers have a requirement that their end users have a firewall and they want to put a IP address in the allowed list of that firewall. But if this DNS name is there, their firewall is not accepting DNS. They need a IP address for it. So we can still design a solution in that case. We can have a network load balancer, let it have a static IP, and then receive it if required. Can I have one ELB and a few multiple target groups? Yes, absolutely, you can have that. And that you would be probably doing. Let me show you an example so that you can understand what I am talking about here. Let me take AWS project break a monolith, and I'll explain. This is a nice project which you can play around with if you are interested in container and load balancer. Let me put this link here. What we are doing here, that we are trying to deploy our microservices in such a fashion. This is what I am trying to achieve. I would have my load balancer, and this load balancer will have three targets. One container serving user requests, another container set serving post, another container set serving threads. And this you see, this load balancer has multiple target group. If a request comes to API/user, forward here, for API post, forward here, and API thread forward here. So that's how we can go ahead and implement this solution. Should not be a problem at all. So you deploy here your microservices, and if I can get this picture and display it on Paint, you would be able to understand that how exactly my request is getting rerouted here. See this picture. So this is my listener. I am saying if request comes for API/user, forward it to my user service. For API thread, forward it to thread service, and for API post, forward it to my post service. So this rule can be configured on the load balancer setting. So if I go to my listener, and if I go to this listener's properties and edit it, I would be able to say this is one, and now let me add more settings on that particular listener, and I should be able to make changes here. See, this is edit rules, and here I'm saying, all right, I want to add one more rule. When the request is coming with a condition, let's say it is asking for slash images, what I should do then that time, I should forward it to a different target group. If we have, when the request then comes for something else, forward it somewhere. So those all possibilities are there, where I can have multiple targets, and based on the request header, see what options we have. We can forward data based on what, based on information which are coming into header. Let me close this and open it again. So I can add a condition, could be path-based condition, could be HTTP header, could be a query string, could be a source IP, could be host header or request method which is coming in. So these are all the identification criteria, and based on these identification criteria, I would send my request to my backend services. So that is what my load balancer rules can do. All right. Any questions so far? Any doubts? Anyone, any confusions? Anything which is not clear with this load balancers? Okay, so network is also same. Let me quickly talk about in last minutes about the third type of load balancer, which is relatively new, which is called our gateway load balancer. Let's try to understand why somebody would be interested to use a gateway load balancer. Now, load balancing theory is not new. It's not like only AWS implements it. There are already lots of companies who have load balancers available. So can anyone tell me any companies who have load balancers available which are used? Anyone? Any thoughts on any companies who have load balancers available, or you have ever used in your physical world any type of load balancers from those companies, if you are remembering any of them? So there are lots of services like Palo Alto is there. Then you have Checkpoint, Redware, Fortinet. These companies provide you the load balancer. So what if I have a customer who is migrating from on-prem and they are interested to bring their own appliances here, appliances in soft state, like what they are looking for? They are looking for some third party integration. So this is their third party load balancing service, software implementation, third party load balancer, and they want to bring this also as a service to AWS. So no problem. What would happen in this type of cases? I would deploy a gateway load balancer in front. So this will be my gateway load balancer. And this gateway load balancer will then forward traffic to my third party load balancer, and that would then actually forward the traffic to my backend service. So now you may be asking, so why don't you deploy third party load balancer directly? These load balancers are mostly one single appliance. So if that one appliance would fail, one VM will fail, means your request will be down. So what we will do now with this gateway load balancer as a front end, we would be able to deploy these multiple copies of these third party load balancer, and they would keep on making my application highly available. So I have given a single front end, and that front end can talk to multiple backend load balancer, and then these will forward request to my target groups which I am creating here. So that is my third type of load balancer which you will find useful for your customer. So that is called my third type of load balancer, called gateway load balancer. So if I show you how the diagram would look like, with gateway load balancer, your source and destinations are here. Source traffic will be forwarded to gateway load balancer, and then gateway load balancer will forward it to the fleet of third party services who are running. Once they check traffic, receive traffic, they would forward requests through gateway load balancer back to my destination. So it is just sitting in the path, and it is ensuring that they are running in a highly available fashion. This will perform health check, it will take care of stickiness, it will take care of flow routing. This whole thing will be taken care by my gateway load balancer. So this is sitting in the path. This will take care of L3 forwarding, and L4 forwarding will be taken care by your backend third party services. So that is what this load balancer is all about. Right. So hopefully everyone has a better understanding about load balancer now. I have 5 more minutes left. I would keep it if there are any questions so that I can respond to those questions if somebody has any doubts or any confusions on what are different type of load balancers are there. So we discuss what load balancers are, three type, and then I have tried to explain you the benefit and what are the ways to implement, and we focus mostly on application load balancer, but that doesn't mean other application where other load balancer doesn't exist. Any questions so far? Any doubts? Any confusions? Would you use internal load balancer between app and DB server? Answer is probably no, Olga. DBs are not like that. DBs are state oriented mechanism. Let me try to draw that thing for you, that how DB works. So when you talk to a DB, a database doesn't work by accepting connection from multiple sessions. When a client is connecting, that DB would expect that the session would get authenticated and continue. So DB we sometimes call they are stateful. And the connection you establish here, it is your JDBC or a ODBC connection, not a HTTP connection. At the top of it, it is still HTTP, but the connection is JDBC and ODBC. And this won't work if one time request comes from one node, another time comes from another node. So that won't work. So in case, let's say this is my web server, fine. But when I have my application server talking to DB, between app and DB, I won't be having a load balancer. Apps would be making direct communication to load balancer. If you are concerned about performance, then we would be able to have a different approach. We can create multiple read replicas here. Maybe we can create caching services, but it would not be a load balancer in front of a database service. Right? Any further questions, any doubts, any confusions? You're welcome. Anyone, any doubts, any confusions so far? All right. Now, one more thing, all these things can be monitored. In the sense, whatever your load balancer is doing, is it running as a capacity? Are we getting errors? So those whole thing can be monitored. There will be a monitoring option with every load balancer you deploy. Here you can check how your targets are, how many requests are coming in. Do we have 400 errors, any 500 error? How many of my 500 ELB error happened? How many active connections are there? How many new connection counts are there? So these all monitoring options are built in like any other AWS services, because we are trying to create a architecture where everything can be monitored, should not be a problem at all. Now let me ask you one more question to you before we call it end of session. Now, if you see this picture, what is happening here? My users are sending requests to my load balancer, and now my request is being forwarded to these multiple processes. Let's ignore DynamoDB for now. Can anyone tell me, in this particular diagram, is there any single point of failure in this box of red? Can anyone think of a single point of failure? If that fails, then we would have problem. Anyone? Any thoughts? Anyone can think of any single point of failure in this particular situation? VPC, answer is no. VPC is a managed service, so we will take care of that. So managed services are taken care by AWS, no problem in that. Can load balancer fail? Anyone? What do you think? Can a load balancer fail? Will there be issues with load balancer? Can it happen sometimes? Yes, it can fail sometimes. But what we do as a managed service, for you and me, when I'm deploying, I am seeing one load balancer. But what would be doing, what AWS Magic will do at the back end, they would deploy this in this format. One would be active and another availability zone will be a standby. So for you and me, it looks like that is one, but what is happening here, that we have deployed them into a active and standby fashion. So even if the whole availability zone goes down, standby will pick up and will keep on moving forward. Should not be a problem. Rizwana says net. It could be, but see, I have a net into one of my availability zone. This is one availability zone A, and I have a net into another availability zone also. So if this fails, then I would be able to use this. If this fails, I would be able to use this. So this will not still be a single point of failure because we have deployed them in pair. This looks one, but it is also deployed in pair. There would be multiple active and standby created for you. You don't see them, but at the back end, this is how it is working. So that's how your load balancers would be working. All right. Any questions so far? Any doubts? Any confusions? So hope you enjoyed, hope you learned something new and got little more clarification about how load balancing work. And hopefully we will see. So is it ELB? No, there is no single point of failure. Will there be another session? Yes, it would. There would be more sessions coming up. So check with your contact point for your program, and there will be more session coming up. So you should be able to see more information, right? So have a good evening, everyone, or good morning, or good night, depending on where you are, and hope to see you in some other session. Thank you so much for attending.
Thanks so much, Ashish, for your time. Really appreciate it. I know it's pretty late there, but really appreciate it. Thank you so much.
No problem at all. Happy to help, sir. Thank you.
Yeah. Yeah. Thanks everyone for joining. This session is recorded and it's going to be put it across in your Canvas session. Thank you.
Thank you, everyone. Bye.
Yeah. Thanks everyone. Bye bye.